Okay. So a little bit more revision. A little bit more revision. Actually, let's keep this. There we go. A little bit more revision. We're going to look at areas of sectors, arc lengths, and a bit of revision on logs. So areas of sectors and arc lengths. You do learn a new formula. A equals half r squared theta and L equals to r theta. Now it really comes down to if you want to learn these two new formulas. They are helpful because your angle is in terms of radians, and mainly that's what you'll be dealing with. So they are good to know if you really want to learn them. However, I will quickly just prove that you don't need to know them if you don't want to. So if you don't want to go and learn two new formulas, you can get away without it. So if I asked you just back in like year 9 and year 10 to find the area of a sector of a circle, obviously you know that would be pi times 5 squared times you would have done 30 degrees on 360. You plug that into our calculator, that gives us pi times 5 squared times 30 on 360, 6.5. And then if I'd use this formula, it would look like this. So half r squared times 5 squared times theta needs to be in radians. That's really important to note. So if I give you 30 degrees, you have to obviously go and divide by 180 and put a pi on top. If you had done that, I'm sure if you can see that the numerator all becomes 5 squared times 30 times pi, 5 squared, 30, pi. The bottom would be 2 times 180, which is 360. You end up with the exact same result as you're meant to. So you can either learn a new one or not. It's really important that you remember the theta is in radians, whereas if you're using this formula here, your theta is in degrees. So that's super important to keep in mind. And again, same thing. If I asked you to go find the arc length here, you would have used your circumference formula, 2 pi r times theta on 360. And then, of course, you would have ended up with an answer that is times 30 on 360, 2.6. And then, of course, if you had done this formula, L equals r theta, 5 times 30 on 180 and put a pi on top, of course, it's still going to give you 2.6. So it's up to you. If you want to go and learn two new formulas, they will teach you this, of course, in school. If you want to go and learn it, go and do that. Or if you want to just stick to the way you've been used to it, you can do that as well. Any questions at this point in time?
No.
Let's have a look at some of these questions using examples. Here it is. So of course, these basic ones are straightforward. You can either follow the formula, find the arc length of each sector. That's in degrees, whereas that's in radians. So just be aware of that. So if I was to find the arc length for this one here, I can just go, if I want to use the formula, it'll just be 10 times 3 pi on 4. So that's very easy, and then you simplify, whatever. That's easy. If you had to do it our way for this question here, you gotta remember you can't use radians, you can only use degrees. So circumference equals 2 pi r times theta on 360. You've got to work out what theta is. If theta is 3 pi on 4, you've got to convert pi as 180 on 4 in your calculator, which gives you 135, and that's the angle you would use. And then that would give you the same answer as this one here. So 15 pi on 2 and whatever that is in your calculator. Does that make sense to you guys? 23.6. Eden, all good as well?
Yeah.
So what do you think you're going to go for? You're just going to interchange, or you're going to just stick to the one, or I don't know. What do you think? You got to pick one. You don't really want to do both. So
Um,
I'll leave that with you. Maybe it's too early right now. But
yeah.
I just wanted to show you that you don't really need to think, because you started off saying, hey, can we go through areas of sectors and arc lengths? And it seems like you think that's different to what you've been doing back in year 9 and year 10, but it's not. It's exactly the same, isn't it?
Yeah.
So, yeah. Let's do question 3. Calculate the exact area of the shaded region. All right, to find the exact area, I think we all know by now you're going to do the bigger one, take away the smaller one.
Mhm.
So let's go area 1. Or area equals area 1 minus area 2. Area 1 would be, what do you want to do? Do you want to use your formula, half r squared theta, or do you want to use pi r squared? What do you guys want me to use? You got to make a decision.
R squared.
Pi r squared, you're more comfortable with that? Because you probably memorized that already, right?
Yeah.
24 squared times theta, 60 degrees on 360. That's it. That's the area of the big one. Minus, what would the area of the smaller one be?
Would it be 24 divided by 2? So it'd be, no. The radius for the smaller one would be 12.
Yeah, and then times by 60 on 360 still. And then whatever that gives you is the exact area. Oh, okay. It does say exact. So that means you can't just go and plug everything into your calculator, right? So when it says exact, put everything except pi in your calculator. So I'm going to do it like this. 24 squared times 60 on 360. That gives me 96 pi. Minus 12 squared times 60 on 360. 24 pi. Because you didn't put the pi in your calculator, your final answer will obviously still have pi's, but it's in exact form. Otherwise, if you put pi's in your calculator, it's stuffed up. It's gone. You've got decimals now.
Yeah.
Any questions? Tiana makes sense as well?
Yeah.
Good. The others here. Sandra is here now. Bit of revision. Calculate the perimeter of the shaded region. Find the perimeter. Obviously, it's going to be 24 plus 24 plus. Sorry. The shaded region, right?
Yep.
12 plus 12 plus this plus this. So perimeter equals 12 plus 12 plus, we're going to call this one, let's say L1 and then L2. So L1 plus L2, L1 equals, okay, circumference formula, 2 times pi times radius, 12 times 60 on 360, L2. L2 equals 2 pi r again, but radius is 24 times 60 on 360. It does not say exact, so you can get decimals and then just go ahead and add it up. And if we look at the answer, question 3, there it is. You don't have to leave an exact. I did, because why not? B didn't have to. There it is in exact form as well. And you can see I've just used 60 degrees on 360 because I can. I'll use the formula. All right, any questions? No, makes sense.
Yeah.
Okay. Move on, let's move on. Let's do, I guess we'll do question 7. Yeah. 7. All right, let's do question 7. This would be exam style question. So very likely to be an exam, something like this. It says, but it's exactly like pretty much the same as what we just did. The perimeter of the shaded region is 80. Show that theta equals to this. Okay. So the perimeter is 80. You know what we're going to write, yeah? We're going to write perimeter equals r plus r, so 2r, plus this length, let's call it again L1, plus length 2. And then obviously, what are we going to find? Eden, what do you think we're going to find first?
R.
No, not really, because you're going to have theta in terms of R. Replace that P for 80. Now look at it. What do you think we've got to find?
The L, the length.
Yeah, you have to find the length L1 and L2. So you can actually plug it into here and start solving for theta. So L1 is equal to, so you've either memorized that formula, which is just R times theta. If you haven't, then you're going to use 2 pi R. So 2 times pi times R times, it says theta is in radians. What does that mean? What would you usually do to this angle if it was in radians? Think about it. If it was like 3 pi on 4, what would you usually do? The pi becomes 180 degrees. Right?
Yeah.
You're timesing by 180 on pi. Now, did you know that that's what you're doing? Let me show you guys another way. Look, we were doing 30 degrees, right, to radians. How did you move 30 degrees to radians? You would have done 30 divided by 180 and put a pi on the top, right? Now, what we taught you guys is just to go from radians to degrees, just replace the pi for 180. The truth is you're not just replacing pi for 180. What you're actually doing is you're multiplying this side by 180 on pi. And then what happens is the pi's would cancel out and you're actually multiplying the top by 180. So let me show it to you. So 30 degrees. You would divide by 180, which is pi on 6, right? And then what we've taught you guys is just to go from pi, just replace it to 1 for 180. But the truth is you're actually doing this. And then what happens is the pi and the pi cancels out, and you're actually getting 180 on 6, which just so happens to be 30 degrees again.
Oh.
So sorry? Yeah?
Yeah, okay.
Yeah, whereas obviously I've never said that or showed that because you never needed to worry about it so much. But it's important to now that you guys are starting to learn degrees and radians, it's important to know what's really happening. What's really happening is your degrees to radians, you're actually multiplying it by pi on 180. Obviously the opposite of this way. But what we say to you guys is just go 30 over 180 and put a pi. But the truth is that's what you're multiplying by. If you're going this way. If you're going this way, you're multiplying this one by 180 on pi. So the exact opposite. So same as this question here. If I did that, you can probably see this and this will cancel out now. Oh, sorry, there's your theta. I times it by 180 on pi. This and this will cancel out. And what are you left with? 360 r theta, 360 degrees r theta. Something's going wrong. Hold on. Gone wrong. It equals 2 pi r times theta radians, which is theta times, oh yes, sorry. Don't forget, this is theta times 180 on pi, right? That's just to get into degrees. What do you got to divide this whole thing by?
Pi? Oh,
Okay.
okay.
Now remember, isn't the formula theta on 360? Well, theta is in degrees. Yeah. You get me? So degrees, theta, degree, and then over 360. Now what happens? Look, pi and pi cancels. 2 times 180 is 360, 360, and 360 cancels, you're back to the formula that you're used to, which is just L equals to R theta. Or in this case, it's still R theta. So we're up to here now, plus L2. Let's do that again. So L2 would be 2R, because your radius is 2R. So 2 times pi times 2R times your angle. Your angle is not just theta, it's theta times 180 on pi over 360. Because it's all multiplied, your pi and pi cancels out. 2 times 2 is 4R. So you're left with 4R theta times 180 on 360, and then pretty much simplify that. What's that? 4 times 180 on 360 is just 2. So the answer is 2R theta. So yes, it would have been a lot easier if you knew your formulas. L equals to R theta. You can see the radius is just 2R. You can just times it by theta. That's great. But I'm just trying to show you, if in case you didn't want to memorize your new formulas, because you don't need to, you can get away with it without it. And plus, probably really good for your algebraic skills to understand all the cancellations. And then once you're at this stage, all we're going to do now is just rearrange to make theta the subject. So I would subtract 2R. So it would look like this. 80 take away 2R equals, factorize your theta out. R plus 2R. R plus 2R is 3R. Divide it. And you're done, aren't you? You get exactly that result. All right, I'll stop there. Any questions, you guys? There probably is. Just let me know where, maybe in the degrees and radians, do we understand that bit? I'll redo this bit. Any questions? No.
No.
Okay, hence show that the area of the shaded region is given by this. Same thing, again, if you knew your formulas, like if you knew that formula for in radian mode, great, makes your life a little bit easier. If you didn't, no dramas, we'll just use pi r squared. Pi times, so to find the shaded region, again, you guys know what we're going to do. We're going to do the bigger one, take away the smaller one. So we'll do the bigger one first. Pi times 4r squared, right? Because 2r all squared would become 4r squared. Do we understand that? The radius is 2r, and when you square it, times by theta. Again, theta has to be in degrees if you're going to use pi r squared. So you times it by 180 on pi, and of course you're going to divide by 360. Pi and pi cancels, as it always will. 4 times 180 is 720. 720 on 360 is 2 r squared theta. Any questions there?
No.
And then obviously you want to try the next one, Eden. Area of the small one. Area big, area small. What would you write? Pi times?
Theta.
Pi times r squared times
Theta over.
you can't say, just can't say theta over 360 because theta is in radians.
Oh, okay.
It's not 30 degrees. Because it's in radians, you got to change it from radians to degrees. So theta times 180.
180 over pi.
That's now you're
by
degrees over. Yep.
360.
That's it. That works. See, this one here, look, I'll just show you. This one here, no dramas. 58 degrees on 360, right? You're happy.
Yeah.
This one here, because it says theta is in radians, you can't just use theta. It's not a degree. So you've got to convert it to degrees, which is like that, and then over 360. And then, yeah, and then you're done with that. And then 80 on 360 is a half. So the smaller one's just half r squared theta. Yep.
Okay.
And I guess just to finish it off, area equals 2r squared theta minus half r squared theta. Obviously, you guys can tell what's missing from this compared to what I have. And obviously what they ask you to do in A. So what's missing? Tiana, what do you reckon? What am I trying to say? What's missing? What's the difference between this one here and this one here?
I'm so lost right now. I don't know how. This just B just confused me.
Okay, I'll come back. I'll get to it, but just try to answer that question. That's okay, because you can answer it. Look at that expression and look at that expression. What's because you got to learn what I'm trying to say here. It's important for once we move into year 12, our more advanced questions. We've got to be able to go, okay, this is what they want me to show. This is what I have, and then obviously what's the difference, and then you'll know what to do. So this is what you've got. This is what we need. What's the biggest difference between the two?
To me, that it's 40.
Other than that, keep going.
It is still there.
Yeah, that's the bigger one.
Okay.
Theta is still there, right? The fact that theta is still there tells you that what do you got to do? What do you have to do in your next step? We're here. Substitute the theta you just found in A into here, so that your expression here will only be in terms of r's. So let's have a look at that. I'm going to factorize theta out because it's a bit easier to work with. Then you're left with 2r squared minus r squared on 2. Theta is this big thing. 80 minus 2r on 3r times by common denominator. All right, you know what? I'm going to redo this whole question because I hate the way it's turned out. Like it's just, I'm losing space and I need to just start again. But that's okay. Let's do it again. Let's do it again. It's fine. I'm doing it again because I know this one here will be very likely to come into you, pop up in your exams. So I'm willing to give it another shot. Okay. All right, let's start again. The perimeter of the shaded region is 80 centimeters. So part A. We know that the perimeter of the whole thing is 80. And obviously that would be R plus R plus L1 plus L2. So perimeter equals to R plus L1 plus L2. And of course, you know, perimeter is already 80, which equals to 2R plus L1 plus L2. Now, L1 equals to circumference, right? So 2 times pi times R times usually theta on 360. Why are we not allowed to write that?
Radians.
Theta's in radian. That's all. But you're allowed to write theta. You're still technically allowed to write this. It's just that your theta can't be just 360. So your theta has to be in degrees, and the way we do that, we multiply it by 180 on pi. Are we comfortable with that?
Yeah.
L2. L2 is 2 pi, and it's not just for Tiana, it's everyone. Like if you're not comfortable, you gotta let me know now. Radius, your radius is 2r. And then again, same thing, pretty much theta times 180 on pi on 360. Start canceling. This is all multiplied. So that's gone. 2 times 180 is 360 and 360 gone. So you're just left with r theta here. This one, your pi and pi cancels. Pretty much 2 and 180 is again 360 cancel. So you're just left with 2r theta. Finish it off. You've got 2r plus r theta plus 2r theta. R theta plus 2r theta. I didn't realize this before, but that's just 3r theta. Subtract your 2r and then divide. All right. Are we comfortable with that? Everybody.